probability axioms or probability rules. Let's start with 3 basic rules, and pretty much everything we're going to do with probability is going to follow from these, okay? Number 1 rule. The number 1 rule is that the probability of any event is just a little number in the unit interval, 0, 1. That is, probabilities can never be negative. Right? Doesn't make sense for there to be a negative 10% chance of rain, and also it doesn't make sense for probabilities to be greater than 1 or 100%. Okay, so again, so 0 is the same as 0%, and 1 is the same as 100%. Okay, you can't have a 110% chance of rain. Doesn't make any sense. Number 2, the probability of getting some event in the sample space is 1. Remember, this Venn diagram is sort of like a nice cartoon of where our experiment is going to take an outcome, right? This is the sample space. This is the sample space. When you do an experiment, whether you're picking a card at random or carrying out a survey or something, whatever happens somewhere inside the sample space, okay? Finally, number 3, axiom number 3. Number 3, if you have disjoint or mutually exclusive events, E1, E2, etc., then the probability of their union is equal to the probability of equal to the sum of the probabilities. What that means is, okay, so first of all, events are disjoint if they don't overlap. That is, if they cannot occur at the same time. These events are disjoint, okay? Maybe this is the event that you get an A in your class, and this is the event that you get a B, and this is the event that you get a C. And then maybe, over here is the event that you get a D, and over here is the event that you get an F. Hopefully that's pretty small. And then all of the remaining space here is the event that you get something else. What else could you get? Maybe you could get a W, or something like that, okay? I don't know, but all these events are disjoint, certainly. You cannot get an A in a course and get a B at the same time, right? But if you want to know what's the chance that you get an A or a B or a C, one of those 3 grades, then the chance is just, you can find that chance just by summing up the chance that you get an A plus the chance that you get a B plus the chance that you get a C. Right? You can think of it also as the amount of paint that you need to paint the total area that's swept out by region A, region B, and region C together. That amalgamation is just the sum of the amounts of paint for each region. All right? P is for paint or probability. Okay? P is for paint or probability. Now, in general, though, you can have events overlapping, right? It's possible to get an A in a course and to win the lottery, okay? This is the event that you win the lottery, let's say, okay? This is the event that you win the lottery. It's possible to do both, and that'll happen. It's not very likely, I guess, but it'll happen right in there. Right? So if I want to know the chance that I either get an A in the class or win the lottery, because hey, guess what? If I get an A or win the lottery, then that makes for a pretty good deal, right? Or a pretty good day, right? If either of those things occur or both, okay? So basically, if I want to know the chance that I get some, the outcome occurs somewhere in this amalgamation here, I can write that as the probability of A or L, right? It's the probability of A or L. And so that's equal to the probability of A plus the probability of L minus the probability of A and L. And here's why. Okay? If I want to know the probability that I either get an A or win the lottery, that should be, can't I write that as the probability of A, this area in here, plus this area here swept out by L. But then when you look at this, I've actually, see what I've done there? I've actually swept out this middle region 2 times. So now I've got to subtract it off. I have to subtract it off. Okay, so that's why I have to do that. Okay? Now, If A and B are disjoint, then the probability of A union B, if I take the union of two events, the chance of that union then is just the chance of A plus the chance of B, because in that case, if A and B are disjoint, if they're disjoint, then this is 0, right? If they don't overlap, okay? Also, we have something called the rule for complements. The rule for complements says that the chance of A complement is just 1 minus the probability of A. This follows by the probability axioms. We can actually prove this here. I know that 1 is the probability of getting something in the sample space, right? This is by axiom number 2 up there, right? But I can write the sample space as the union of A with its complement, right? Either A occurs or the complement of A occurs, for sure, right? Also, by axiom 3, I can write this as the probability of A plus the probability of A complement, right? Because A and A complement are certainly disjoint. And so that completes the proof, actually. That's it, right? The sum of these two things is 1, if and only if 1 minus either one of them is the other. Yeah, so there you go. All right, probability axioms. Just to be clear, these are the probability axioms right here. Those three things. Those three things up there are the probability axiom. This is a more general rule. Turns out follows from the axioms. This is the rule for complements. It also follows from the axioms. I proved it here. Its proof follows from the axioms, right? Okay, next. For the Venn diagram shown, you see this Venn diagram right there? See it? No. No, you don't, because there isn't one. Let me put one there. Let's say I have the event A is here, and the event B is here. They don't have to all be circles, okay? They can be all kinds of things. And here's C. Let's suppose that the chance that event A occurs is 20%, and the chance of B is 12%, the chance of C is 38%. Then what's the probability of A union B union C? Well, since these events are all disjoint, axiom 3 says that this is the same as the chance of A plus the chance of B plus the chance of C, right? So that's going to be 0.2 plus 0.12 plus 0.38, which is 0.70, okay? Good. Now, what if these events are allowed to overlap? What if instead of the picture up there I have, A is here and the event B is here, okay? And maybe C overlaps with B a little bit, okay? Okay, and maybe we know that the chance of B and C is 10%. So now what's the chance of A and B and C? Okay, well, I can write this by axiom 3. By axiom number 3, this is the chance of A plus the chance of B union. Whoops, I got my symbols wrong here. I'm supposed to be doing unions here, right? So let's correct that. Sorry, don't tell anybody I did that. Oh my goodness. Okay. B union C. There we go. This is by axiom 3 because you see A doesn't overlap with all of this stuff. All of this stuff is called B union C. It's the amalgamation of B with C. Okay? Now, but I can't split this up the same way because B and C actually overlap, right? So, by the general rule, I can write this as the probability of A plus, see this term here is the probability of B plus the probability of C minus the probability of B and C, right? Okay. And clearly, if this is all confusing, then just look at the picture here. Look what you want. You want to know the chance that, if you perform this experiment, your dart lands somewhere in the shaded region. Why? Because if it does, you win a big fat prize. Right? Awesome. So to find the area of the shaded region, it should be this area plus this area down here that is C, right? All of this, plus the area that is B, right? All of this, right? But then minus, you're going to subtract out this part that they have in common, which is exactly what we're doing there, okay? So now I can just fill in the blanks, right? The chance of A is 20%, the chance of B is 12%, and the chance of C is 38%, and I'll subtract off the chance of their intersection. Guess what? That's just 60%. Good. Now, what's the chance that I get something in the complement of the shaded region? That is the chance that I get something that is in the complement of the union there. That's just 1 minus 0.60, or 40%, right? And that rule for complements.